We will continue with section 7E, which is counting and probability, and we'll do pages 7, 8, and 9 in this video. Now, here's an interesting problem. Problem 12. Let's look at it. Suppose you have a party with 20 people, and you are one of the 20 people. So it's you and 19 guests. So what is the probability that at least one of your guests will have the same birthday as yours? So your birthday is one day out of the 365 days in a year. So probability that a person has your birthday, a specific day in the year, one day in the year, so that would be 1 over 365. The next one is, what is the probability that a person does not have your birthday? So this is the opposite event. So it's 1 minus 1 over 365. If you simplify it and write it as a fraction, it's 364 over 365. So what is the probability that at least one of the 19 people has your birthday? So remember, the term at least suggests using the at least rule because it's much easier than listing different possibilities for 20 people in the party. So probability that at least one of the 19 people has your birthday is equal to 1 minus the probability of the opposite event, which is none of the 19 people have the same birthday as yours. So that is equal to 1 minus probability that the first guest does not have the same birthday, the second guest does not have the same birthday, the 19th guest does not have the same birthday. So that is equal to 1 minus probability that the first does not have the birthday and the second does not have the birthday and the 19th does not have the birthday. So that is equal to 1 minus 364 over 365, 364 over 365, all multiplied together. And there are 19 people, so it's 1 minus 364 over 365 to the 19th power, which is equal to about 5.3%. So there's a small chance that at least one of the 19 other guests will have the same birthday as yours. Now next, we still have the same 19 guests. What is the probability that some pair of guests shares the same birthday? That is the same as saying at least one pair shares the same birthday. Now, the minute we use at least, that should remind us of the at least rule, that is equal to 1 minus the probability that the opposite happens, opposite of at least one pair shares the same birthday. What does that really mean? What it means is that no two people share the birthday, which means all 19 people have different birthdays than each other and, of course, yours. So 1 minus probability of each one of these having a different birthday is 364 out of 365, 363 out of 365. We need to start excluding the people who come before. So our first guest cannot have the same birthday as yours, so he has a choice of 364 over 365 birthdays. So that's the probability that his birthday will not be on the same day as yours. Now, the second guest cannot have the same birthday as the previous guest and the one before, so it would be equal to just 363 out of 365, and keep going on and on. So that would be that simplifies to this expression, and when you use your calculator, you get 0.4114. So 40.14% of the people, 40.14% chance is that of at least one pair sharing the same birthday. So that is quite a good chance of that happening. Probabilities, some problems related to probabilities where you have to use the counting techniques. So find the probability of choosing five numbers that match five randomly selected balls when the balls are numbered 1 through 42. So we have a specific selection in mind. We're choosing five balls and we have a specific selection in our mind. We need to find a probability of choosing that one specific um, selection. So what is the total number of selections of five objects, five numbers, taking 42 at a time? So that is equal to 42C5.